Hello. So, Meghana, are you there? Right, Nana. So, today we'll discuss about buffer solution. Buffer solutions means what? When we are adding some small amount of acid or base, there is no change in the pH. So, those generally we are called as buffer solution. Okay. Buffer solutions means what? A solution. So, buffer solutions basically to, for example, CH3COOH, weak acid, plus salt of strong base, right? Weak acid, this is generally we called as acidic buffer. Acidic buffer. Acidic buffer. So we'll see exactly how it works. So what I'm trying to say is, when we are adding some small amount of acid or base, there is no change in its pH. So means, for example, weak acid, CH3COOH, CH3COO minus H plus, CH3COONA gives rise to H3COO minus Na plus. Here we can say it's a common ion effect. For example, if you are adding some small amount of acid, acid means what? For example, HCl we are adding. HCl means 100% H plus is coming, right? When H plus is coming, H plus concentration is increases in the product side. Because of the concentration in the products increasing, by default what exactly happens? The reaction moves to the backward direction. Means actually we know that pH is equals to what? Minus log H plus ion concentration. Right? We know that pH is inversely proportional to H plus ion concentration. If we are adding the H plus ion concentration, automatically what exactly happens? So pH should be decreasing. But here is there is no change in the pH when we are adding some small amount of acid. Or if you are adding some small amount of base also, there is no change in the pH. If you are adding the OH minus, this OH minus and H plus, neutralization reaction takes place, it becomes water. So by default what exactly happens? H plus concentration is decreases this side. When H plus concentration is decreases, what exactly happens? Forward reaction takes place. How many H plus ions are decreased? That many H plus ions are given by the CH3COOH. So automatically there is no change in the pH. So if there is no change in the pH, so that type of solutions generally we are called as, right, buffer solution. So buffer solutions are, so generally this is acidic buffer type of solution. So generally weak acid, can say weak acid plus its salt of strong base. Its salt of strong base. So this combination we are called as, buffer solution. So just write it down. Write the points. క్వశ్చన్స్ ప్రాక్టీస్ చేసి రాస్తావు ఎగ్జామ్స్ నాన్నకు మెసేజ్ రాస్తావా మరి ప్రిపేర్ ఒక్కొక్క ఏ చాప్టర్ చాప్టర్ చెప్తే ఏ రివిజన్ ఏది పట్టుకున్నా చదవాలి. ఇప్పుడు ఈక్విలిబ్రియం చదవమని చెప్పి ఇప్పుడు చదువుతున్నా. రైట్ రా. A solution, write a point. A solution whose pH does not change. A solution whose pH does not change. Megana Rasai. A solution whose pH does not change on addition of small amounts of acid or base on the addition of small amounts of acid or base or dilution or by dilution is known as buffer solution. Is known as buffer solution. Known as buffer solution. రాసావా మళ్ళీ చెప్పనా? A solution whose pH does not change. Solution whose pH does not change on the addition of small amounts of acid or base or by dilution is called as or is known as buffer solution. Right now. So buffer solution is having, write one more point, is having two parts, acidic buffers and basic buffers. So buffer solutions are two types, acidic buffers, basic buffers. Buffer solutions are two types, acidic buffers, basic buffers. Acidic buffers. I told you weak acid, salt of strong base. Weak base, salt of strong acid. Salt of strong acid. For example, the H4OH, H4. Already gave you 3. H3ONA. The properties of buffer solution. Properties of buffer solution. Properties of buffer solution. Right, it has constant pH. Has constant. Means when addition of acid or small amounts of acid or base, there is no change in the pH. It has constant pH. Next one, it does not change with on dilution. Does not change does not change with dilution. And it does not change on standing for the long. Does not on long standing. On long standing. Or standing for long also we can say it does not changing for standing for long. You can write like that, but better word. Does not change on standing for long. It does not change, right? The pH does not change. pH does not change on addition of small amounts of acid or so very important, which of the following statements regarding buffer solutions right or wrong doesn't matter. So like that they are asking the question. So pH does not change addition of small amounts of acid or base. So here is one of the important thing to understand. Let me know. Completed? Huh? Next put the heading on buffer action. Buffer action. Buffer action. Buffer action. Write that statement. Buffer action. Action of buffer solution. Action of buffer solution on addition of action of buffer solution. Action of buffer solution on addition of small amounts of acid or base. On addition of small amounts of acid or base. Acid or base by which it resists the change in pH. By which it resists change in pH. By which resist change in pH. I told you types of buffer solution. The buffer action, the action of buffer solution and addition of small amounts of acid or base, right, by which it resists the change in pH. This is change in types of buffers, Nana. Buffer solutions. Simple buffer. Simple buffer means one component. So means we can say weak acid plus weak base. Only one component is there. Weak acid plus weak base. Weak acid plus weak base. Salt means we can say salt of CH3COO, and this is not that much of important, right? Full buffer. Mixed buffer I already told you. Simple buffer. Second one is mixed. Second one is important. Simple buffer, weak acid, weak base. The salt of weak acid, weak base. Right, wrong. Mixed buffer. Mixed buffer, two types. Buffer, I already told you, two components. Two components. One is acidic buffer. Acidic buffer. Second one is basic buffer. Mixed buffers, one is acidic buffer, second one is basic buffer. Put the heading acidic buffer. Acidic buffer, a solution contains weak acid. A solution contains weak acid and its salt of strong base. Salt of strong base, known as acidic buffer. I told you weak acids. For example, CH3COOH. Weak acid and its salt of strong base means what? So weak acid with strong base, for example, NaOH. Right? We'll get CH3 ONaH2. This is salt. So CH3 COONA. Weak acid and its salt of strong base. This combination I already told you in the beginning, right? So this we are called as acidic buffer. So we can take example CH3COOH, CH3OOK, HCOOH, right? HCOONA. So like this combinations, we will get n number of combinations. So we need to identify, and year one complication is going to come. So that I am going to explain right now. First write this example. Calcium, also big buffer. Benzoic acid is weak acid. This combination, if they are giving this combination, 2OO, they're all acidic buffer. Generally we can say acid and its conjugate base. Acid and its conjugate base with the salt, of course, those are all acidic buffers now. For example, H2S plus NaHS. NaHS. So NaHS also we can take plus Na2. This is one type of buffer. This is other type of buffer. Two types. Then Niraja vintunnava? So here is one more important thing, Ra. For example, try to understand H3PO4. H3PO4 is in how many types? See, the combination H3PO4 plus H2PO4 minus. This combination, one type of buffer. And second type, let me know. H2PO4 minus plus HPO4 2 minus. This is acid conjugate base, right? Acid conjugate base. I told you, what is conjugate base? From acid to conjugate base, how we will get? Removal of H plus. So here onwards, I removed one H plus. Here to here. One more also is coming, right? H PO4 2 minus plus PO4 3 minus. So three component, three buffer solutions we get from 1, 2. So whenever the negative charge is there, so put Na or K like that. So automatically we'll get these three types of buffers. We need to identify when they are asking the questions, we need to identify so which type of. You know, write a question. This is very important question. Which of the following will form acidic buffer? Acidic buffer. Which of the following will form acidic buffer? For example, CH3 OOH, AOH. This combination. Imagine I'm just giving 1 mole of this, 1 mole of this. Right? This is one combination. Number one question. Number two, same question. So this is 2 moles, this is 1 mole. Third one, S plus OH. 1:1. Fourth question. 2:1. 2:1. So now let me know which solution will form the acidic buffer. One is to 2:1. If we are taking 1:1, what exactly happens? H3O NaH2. After the reaction, so what is the remaining? Only starting is 0, 0. Then afterwards 0, 0. This is 1:1. Of course, only only salt is there. Only this is nothing but it becomes salt hydrolysis. Salt hydrolysis. Is salt hydrolysis, not a buffer solution. In this case, it's forming a buffer solution. H3COO NaH2O. So starting nothing. So after 1, this is 1, 0, 1, 1. So means after the solution in the resulting mixture, weak acid and salt of strong base. This combination should be present. But in the above case, there is no weak acid. అర్థమవుతుందో ఏం చెప్తున్నాను? What is buffer solution? Buffer solution means weak acid plus its salt of strong base. ఈ combination undala, right? This combination should be present. But exactly ఈ కేసులో ఏమవుతుంది, right? So only salt is remaining. So here is no weak acid. ఇక్కడ weak acid మొత్తం కన్జ్యూమ్ అయిపోయింది. 1 mole కి 1 mole కన్జ్యూమ్ అయిపోయింది, right? There is no, means buffer solution means what? It should be compulsory present. Weak acid 2 moles తీసుకున్నాం, ఇది 1 mole. 1 mole కి 1 mole కంప్లీట్ అయిపోతుంది neutralization, but 1 mole is remaining. This is 1 mole and this is 1 mole. This combination is forming is a buffer solution, means second one forms the acidic buffer but not first one. So we need to see the ratios. Of course, third one won't form. It's also salt hydrolysis, but the fourth one is forming a buffer solution. So like this, very, very important case. Whenever in the question, if they are giving these concentrations, not only 1 mole, for example, it is giving 3 moles. If it is giving 3 moles, it becomes salt hydrolysis. They are asking to calculate the pH. So that cases we need to use, right, salt hydrolysis pH. So last class which I discussed, right? So pH formulas idea unnaya ninna cheppine KH H pH idea unnaya nenu cheppina pH formulas. So aa formula vaadala. Buffer solution ki vere pH ippudu nenu cheptanu. Write it down. Here ganpi ఇప్పుడు కూడా అవుతుందా? నీరజ అర్థమైందా? రెండు సార్లు వస్తుంది. right? Right, I already explained how the buffer solution will work, right? Buffer solution అంటే ఏంటి? ఇప్పుడు మన డైట్ కూడా ఒక బఫర్ సొల్యూషన్. వెనెవర్ వీఆర్ ఈటింగ్ సమ్ స్మాల్ అమౌంట్స్ ఆఫ్ యాసిడ్ బేస్ మీన్స్ కూల్ డ్రింక్ తాగుతారు కదా, రైట్? యాసిడ్ బట్ మనకేం కాదు, కొంచెం తాగితే ఏం కాదు, అదే పనిగా తాగితే హీట్కి, రైట్? అంటే దెర్ ఇస్ నో చేంజ్ ఇన్ ద pH ఎందుకంటే వెన్ వీఆర్ యాడింగ్ సమ్ స్మాల్ అమౌంట్స్ ఆఫ్ యాసిడ్ బేస్. సో పర్టికులర్లీ నా pH calculations are H3 minus A plus 3 OH, weak acid. We know weak acid H3 O minus H plus. So Ka value, how can we write the Ka value for this? H3CO minus H plus and concentration by H3OH. So now we need to calculate the pH, right? pH means what we need to know. What is pH? Minus log of H plus ion concentration. Means what we need to know? We need to know the H plus ion concentration. Now H plus ion concentration is here, right? So H plus ion concentration, write it down left side. So means, hello, how can we write the H plus ion concentration? So we need to write the left side. H plus ion concentration is equals to, come on, let me know how we have to rearrange. Ka into H3OH by H3CO. So is it clear? Any confusing? ఇది ఇక్కడికి తీసుకొచ్చా, రైట్? సో దీన్ని ఎలా అంచి దీన్ని డౌన్ తీసుకో, విల్ గెట్ దిస్. అర్థమవుతుందా? హలో. సో నౌ అప్లై ద లాగ్ both sides, right? Log H plus equals to log Ka log H3OH by CO minus nothing but salt, acid by salt, right? Multiply with minus, right? Multiply, I am just writing the multiplying here only, okay? Minus log H plus is nothing but what, no? pH equals to minus log K pKa, right? So minus log, right? So ఇక్కడ ప్లస్ రాస్తున్నాను, ప్లస్ లాగ్, అప్పుడు ఏమవుతుంది? రివర్స్ అవుతుంది. సో దిస్ ఈజ్ సాల్ట్, నాను, దిస్ ఈజ్ యాసిడ్. సో బికాస్ మైనస్ ఐఎమ్ రైటింగ్ ప్లస్, సో ఇట్ విల్ బి రివర్స్. సో సాల్ట్ కాన్సన్ట్రేషన్ బై యాసిడ్ కాన్సన్ట్రేషన్. లేదు సార్, నేను ఐ వాంట్ టు రైట్ యాజ్ ఇట్ ఈస్ మీన్స్ పుట్ మైనస్, reverse it, acid concentration by salt concentration also we can write, but the thing is we need to know this formula. pH is equals to pKa plus log salt by acid concentration. Come on, write it down. This is the formula, important now for pH of acidic buffers. For basic buffers, POH is equals to pKb log salt concentration by base concentration. Same అదే మోడల్. So write it down. I am not deriving that base. Right? POH is equals to, tell me, PKB plus log salt concentration by base con. POH is equals to PKB log by base con. Then write a question. Meghna Rasava. Rasava రాయలేదా? No. Do it. Write it down first. Then write a question. Calculate the pH of a solution. Calculate the pH of a solution containing. Calculate the pH of a solution containing 0.1 molar acetic acid. Right? Its Ka value equals to 10 to the power of -5 and 0.2 molar of H3OON. Calculate the pH of a solution containing 0.1 molar of CH4OH. Ka is given and 0.2 molar of CH3COONA. The question, come on, do it. Let me know the answer. వస్తున్నావా? అది కొంచెం కొన్ని ఎవరు రాలేదా? నాకు కొన్ని చైర్లు బయట ఉన్నాయి, క్లీన్ చేసి కప్పులో పెడతా. వెల్డింగ్ చేయించుంటుంది. కొంచెం తొందరగా. లేదు అన్నీ చాలా ఇరిగిపోయినాయి కదా. లేదు హాల్లో అక్కడ తీసి మేఘన వచ్చిందా? నీరజ? ఇంకా? Tell me the final answer. 5.3. Oh, good. నీరజ వచ్చిందా? యా. So this is a formula, right? But here is Ka, right? Ka means what? pKa. Ka means what? Minus log, right? Minus log power of minus 5. Nothing but directly 5. So 5 plus log salt concentration. Salt now. CH3COONA, this is salt. Of course, this is acid. 0.2 by 0.1. Right? So 5 plus log 2. Log 2 value is how much? Log 2, 0.3010. Nothing but 0.3 we can take. 5 plus 0.3010. Nothing but 5 point or 5 point directly. Okay. Neeraja, Kesava. Then for example, basic buffer for OH. Weak base and its salt of strong acid. Weak base, how can we write? NH4OH gives rise to OH, right? Kb, NH4 plus concentration, OH minus ion concentration by 4 OH. OH minus concentration is equals to 1. OH minus concentration is Kb to 4OH concentration by 4 plus, right? Applying the same log minus, right? Applying the log both sides, log minus log OH minus log Kb log, this is base by salt, right? Now, so minus log OH minus POH equals to PKB plus log salt concentration by base con. Write it down. Kb plus log salt base con. Write a question, bro. Calculate the pH of solution containing pH of a buffer solution containing. Calculate the pH of a buffer solution. Calculate the pH of buffer solution containing 0.2 mole of NH4Cl, NH4, 0.2 mole of NH4Cl and 0.1 mole of what? H4OH, H4OH per liter, per liter means concentrations they are given per liter. Kb for NH4OH is Kb 1.85 into 10 to the power of minus 5. Come on, do this easy question. Same Right now, how we did, same thing. Come on, try it. Right or wrong, doesn't matter. Come on, do it fast. Calculation also, you need to be, you have to do very fast. ఇంతకుముందు చేసా 5 పాయింట్స్ పిహెచ్ అడిగింది. పిహెచ్ అడిగి ఫస్ట్ పిఓహెచ్ క్యాలిక్యులేట్ చేసింది. $8.9 వస్తుంది. సరే, ఇక్కడ మీకు నిన్న చెప్పాను నేను. ఇప్పుడు ఇక్కడ కేబీ ఇచ్చా కదా, పీకేబీ ఎలా చేస్తుంది దీనికి? 1.85 అయింది. నేను చెప్పాను అప్రాక్సిమేట్గా 2 తీసుకోండి. 5 - log 2 అంటే 5 - 0.3 4.7 అప్రాక్సిమేట్. KB equals to -log KB -log 1.85 into 5 -log 5 - log 2 means what? -0.3. 8 point approximately you can take it. 4 points and approximately we can directly take. Sometimes otherwise they'll give the value of for this one exact value. So 4.7 approximately. You can use the 4.7. QOH is equals to 4 pKb is salt concentration by base con. pKb is how much? 4.7 plus salt concentration 0.2 by 0.1. Hey, sorry, log value much. Log value much. 0.2 log 2 మళ్ళీ 0.3. So approximately 5 point something 5 వస్తుంది. H is equals to 1. H is equals to POH minus 14. 14 minus POH. Approximately. Right? POH 14 minus 5. Approximately get 9. Approximately will get 9. Hello? Hello? Yeah. The class lo urgent, huh? నేను ఒక 5 minutesలో చేస్తాను. These are approximate values we did and we took, right? If their values are very close, we need to take the exact values. But generally in exam, they won't give very close. Okay, na? Write one more question. This is just basic model questions. They'll twist the questions the level is increasing. In NEET, one type of questions they'll ask. In mains, one type of question they'll ask. In exit, one type of question. In advanced, they'll ask in different type. Concept is same, but they are twisting. So right now I'm asking the pH and pOH, right? Sometimes they're asking the concentration of the salt or right? This base concentration. Like that, I'll give you one more question. Write it down. How much CH3COONA should be added? How much CH3COONA should be added to 1 liter of 1 liter of 1 liter of 0.1 molar CH3COOH, 0.1 molar CH3COOH to make a buffer of pH equals to 4. So Ka value is given 1.8 into 10 to the power of minus. Put as a homework and do it. So tomorrow I'll finish couple of questions. We'll do this one, and solubility product is last topic. I'll finish that topic, solubility product. Isha, నిన్న రాలేదు, నిన్నటి వీడియో ఉంది చూడ, ఓకేనా? నేను డౌట్స్ ఉంటే అడుగు. నీరజ్, నువ్వు కూడా నిన్నటి వీడియో ఉన్నాయి ఆఫ్ డేస్ చూడు, డౌట్స్ ఉన్నాయి నాకు మళ్ళీ అడుగు. రిమైనింగ్ విల్ కంటిన్యూ టుమారో.